Hello, welcome to a video entitled Exploration of the National Vulnerability Database using OR in the ShinyApp. The first thing to do is to describe what is the National Vulnerability Database. This is a US government repository of standards-based vulnerability information for software programs and firmware. Publicly accessible information, and it is available for download. Having a look at another page on the NVD site, the data is downloadable for a number of years, going from 2020 back through to 2002 in JSON format. The NVD JSON 1.1 schema is given here, and as you can see, it's a nested structure with several different variables, several different types of variables, dates, strings, and numbers. And it's nested, and there are in the real data there are varying levels of this data. Next, we're going to look at some of the particular fields that are stored in this database. In particular, we'll start off with the CWE, the Common Weakness Enumeration. This is a common way of discussing types of bugs. So each CWE has a name and an associated description, and some text about some information about how the vulnerability is manifested. These are classes of vulnerability. They have linkages together. Yes, dependencies, but links. Next, another piece of information stored in the JSON file is the CVSS score. There are a couple of different types of CVSS score, version 2 and version 3, but the one we're going to look at is version 3. It is made up of a number of individual pieces of information which are categorical variables with different levels of different pieces of information, different levels of impact. So the attack vector. The attack vector is a string called network, or JSON network, or local or physical, corresponding to how the vulnerability is exploited. The attack complexity can be low or high. These are all categorical variables. The privileges required are none, low, and high, and so on throughout the debug. At the end, there are additional types of variables, and at the end, when the information is gathered together, a number, the output is a base score, which is a number, and these are based on the number of equations put together. So the data in the NVD database is made up of a number of different variable types, categorical variable types, numerical variable types, dates. And the purpose of the application is to look through the information and to get the general shape of the data. So continuing on, then, there are other sources of information. The MITRE.org site, which has other vulnerability information as background and other information about describing details on the bugs. So for the moment, we're going to leave it at that in terms of describing where the data comes from and its background. The next step is to describe where how the data was treated. What we get out of the NVD database is a JSON file, and it's made up of the various variables that needs to be, well, for our purposes, what I chose to do was to flatten it into a CSV file. For this, I used a Python script. There were a number of variables I chose, a subset of variables I chose to look at for this application, and the Python script picks out the elements of the JSON and flattens it into a CSV file, a comma-separated variable file, which is easily read by OR. The next step is to look at OR itself, and what we can see is a number of libraries are used in this. The ShinyApp is made up of 3 files for the purposes of deployment. App.or, which contains the function that invokes the server and the user interface, the server file, which contains the server code, and the UI file, which contains the UI code. Now, let's run the app. And what we see here is a number of tabs, and there's a left side and a right side. The left side has a selection allows the user to select a base score, the years for the data, and the manufacturer of the software, and then the products associated with that particular manufacturer. So I can select a manufacturer and select all the products or some of the products. The opening page is the help page, which describes what the user will see on the individual tabs. That's welcome tab. The next tab is product. This shows a bar plot of the vulnerability, in this case for all products, although we can choose to have a look at just one product. The number of vulnerabilities reported there, this product. You can mouse over the bar plot displayed in order of decreasing counts, and you can see the individual products. The next tab is the CWE tab, which shows the CWE bar plot of the CWE for all products in this case, or for a selected product. This checkbox switches on or off the selection. We can see that for this product there are a number of CWE types reported, and we can see that there are a number of different the attack vectors are of different significance for this. You can see that the network attack vector is significant for this particular product, and its base severity, high, critical, and low for all these CWEs. The next tab shows the clustering information. The next tab shows clustering information for the selected data. And we can see that we have a dendrogram for the selected product, or we can select all products, and the application will recalculate. Looking at just one for the moment, we can see that there are a number of different agglomeration methods available for the user, which will cause the dendrogram to be calculated in a different way each time. And the selected data can be grouped in terms of clusters and displayed here. The search field allows the user to pick out individual lines or groups of lines. The user can choose to color code the clusters depending on the choice or the number of clusters to display. It makes sense in this case to choose 2 clusters based on looking at the dendrogram. The next tab is the base score tab. This is a numerical variable, as you can see. It's a histogram of vulnerability for the base score for the selected product. It's for all the vulnerabilities that are reported for that product. The next tab is information from the base score and the CWE displayed on a facet plot, a faceted bar plot. What you can see is that there are a number of different CWEs types reported for this product, but you can see the base score for each of the CWEs reported. So this particular CWE is interesting because it has vulnerabilities reported with different base scores. The next tab is categorizing this information with, by machine learning to make an estimate, to make a prediction of which it takes a while to run to make a prediction of which attack vector as you can see, the results are here. What we see now here is for Microsoft for all products. We can see the using the bagging method. You can see that the prediction for the attack vector in this column, and you can see the actual attack vector in this column. Where the columns differ, we can see a misclassification. This information can be used to evaluate the misclassification rate. You can see that the correct classification rates are numbers are high compared to the misclassification rates, and this information can be used to calculate the misclassification rate for the method. The second table is the same problem, classification problem for the attack vector, but you can see that it's a gradient boosted method. You can see again there's the classification rate could be, or misclassification rate can be calculated. In this case, it appears the bagging method appears to perform better. The next tab is a table with the raw data for whatever the selection the user has made on this site. The next section is a table, is the help, which contains a link to this video. Thank you for your time. This is the end of